Hello students, I am Swarnlata Sharma from KV Muradabad. In the last session, we discussed about trigonometry and various types of angle measures. Today, we shall discuss about trigonometric functions. In earlier classes, we have studied trigonometric ratios for acute angles as the ratio of sides of a right angle triangle. We will now extend the definition of trigonometric ratios to any angle in terms of radian measure, and we will study them as trigonometric functions. Consider a unit circle with center at origin of the coordinate axis. Let P of AB be any point on the circle with angle AOP is equal to x radian, that is length of arc AB is equal to x. We define cos x is equal to A and sin x is equal to B. In the figure, since triangle OMP is a right triangle, we have OM square plus MP square is equal to OP square, or A square plus B square is equal to 1. Thus, for every point on the unit circle, we have A square plus B square is equal to 1, or cos square x plus sin square x is equal to 1. Now, since one complete revolution subtends an angle of 2 pi radian at the center of the circle, angle AOB is equal to pi upon 2, and angle AOC is equal to pi, angle AOD is equal to 3 pi upon 2. The coordinates of the points A, B, C and D are respectively 1, 0, 0, 1, -1, 0 and 0, -1. Therefore, we have sin 0 as 0, sin pi by 2 as 1, sin pi as 0, sin 3 pi upon 2 is equal to -1, sin 2 pi is equal to 0. Similarly, cos 0 is 1, cos pi by 2 is equal to 0, cos pi is equal to -1, cos 3 pi by 2 is equal to 0 and cos 2 pi is equal to 1. Now, if we take one complete revolution from the point P, we again come back to same point P. Thus, we also observe that if x increases or decreases by any integral multiple of 2 pi, the values of sine and cosine functions do not change. Sin 2n pi plus x is equal to sin x, where n belongs to set of integers z. Cos 2n pi plus x is equal to cos x, n belongs to z. Further, sin x is equal to 0 if x is equal to 0 plus or minus pi plus or minus 2 pi plus or minus 3 pi and so on, when x is an integral multiple of pi, and cos x is equal to 0 if x is equal to plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2 and so on. That is, cos x vanishes when x is an odd multiple of pi by 2. Thus, sin x is equal to 0 implies x is equal to n pi, where n is any integer. Cos x is equal to 0 implies x is equal to 2n plus 1 into pi by 2. That means, an odd multiple of pi by 2 where n is any integer. We now define other trigonometric functions in terms of sine and cosine functions. Cosec x is equal to 1 upon sin x, x not equal to n pi, where n is any integer, sec x is equal to 1 upon cos x, x not equal to 2n plus 1 into pi by 2, where n is any integer. Tan x is equal to sin x upon cos x, x not equal to 2n plus 1 into pi by 2, where n is any integer. Cot x is equal to cos x upon sin x, x not equal to n pi, where n is any integer. Now, let us discuss some other fundamental identities. 1 plus tan square x is equal to sec square x when x is not equal to 2n plus 1 into pi by 2, n is any integer. We will derive this with the help of the previously known identity, that is sin square x plus cos square x is equal to 1 for every x belonging to R. This we will do by dividing both the sides of the identity by cos square x. We get sin square x upon cos square x plus cos square x upon cos square x is equal to 1 upon cos square x, assuming that cos x is not equal to 0. So, obviously, what is sin square x upon cos square x? You already know it, it is tan square x plus 1 is equal to sec square x. Thus, we have an identity tan square x plus 1 is equal to sec square x. Now, we will take up another identity 1 plus cot square x is equal to cosec square x, x not equal to n pi, n is any integer. This we will do by dividing both the sides of the identity sin square x plus cos square x is equal to 1 by sin square x. We get sin square x upon sin square x plus cos square x upon sin square x is equal to 1 upon sin square x, assuming that sin x is not equal to 0. This implies 1 plus cot square x is equal to cosec square x, where x is not equal to n pi and n is any integer. Now, let us look into the sign of trigonometric functions. Look into this figure. Let PAB be a point on the unit circle with center at the origin such that angle AOP is equal to x. If angle AOQ is equal to minus x, then the coordinates of the point Q will be a comma minus b. Therefore, cos of minus x is equal to cos x, sin of minus x is equal to minus sin x, since for every point P A B on the unit circle A lies between minus 1 and 1, we can write minus 1 is less than or equal to A is less than or equal to 1, and minus 1 is less than or equal to B is less than or equal to 1. We have minus 1 is less than or equal to cos x, which is again less than or equal to 1, and minus 1 less than or equal to sin x less than or equal to 1 for all x. Now, let us see in the quadrants. In the first quadrant, A is greater than 0, B is greater than 0, consequently, all the 6 trigonometric functions are positive. In the second quadrant, A is less than 0, B is greater than 0, so sin x is equal to b and cosec x is equal to 1 upon b are positive and all the other 4 trigonometric functions are negative. In the third quadrant, A is less than 0, B is less than 0, so tan x is equal to b upon a and cot x is equal to a upon b are positive and all the other 4 trigonometric functions are negative. Similarly, in the fourth quadrant, A is greater than 0, B is less than 0, so cos x is equal to a and sec x is equal to 1 upon a are positive and all the other 4 trigonometric functions are negative. This can be summarized as quadrant and T functions which are positive. first quadrant, second quadrant, third and fourth quadrant. In the first quadrant, all the trigonometric functions are positive. In second quadrant, sin x and its reciprocal is positive. In the third quadrant, tan x and cot x are positive. In the fourth quadrant, cos x and sec x are positive. This table can be memorized with the help of a beautiful phrase here, add sugar to coffee. Here, first letter of the word add stands for all. All means all the trigonometric functions sin, cos, tan, cosec, sec and cot all are positive in the first quadrant. Similarly, first letter of the word sugar S, you can take it as sin and its reciprocal are positive and all others are negative. Similarly, first letter of the third word 2 stands for tan and its reciprocal cot. They are positive in the third quadrant, and the first letter of the fourth word coffee indicates cos and its reciprocal. They are positive in the fourth quadrant. The signs of trigonometric functions can be visualized in the plane as shown in the figure. First quadrant, second quadrant, third quadrant and fourth quadrants are seen here. In the first quadrant, all the trigonometric functions are positive. In the second quadrant, sin x, cosec x are positive, cos x, sec x, tan x and cot x are negative. Whereas, in the third quadrant, tan x and cot x are positive and sin x, cosec x, cos x and sec x are negative. In the fourth quadrant, cos x, sec x are positive, whereas sin x, cosec x, tan x and cot x are negative. With the help of this figure, it will be easy to remember the signs of the trigonometric functions, which will help us to solve problems regarding trigonometric functions. So, students, today we studied about the trigonometric functions, sign of trigonometric functions. In the next session, we shall discuss about domain and range of trigonometric functions and solve some relevant examples. Thank you.